AI can feel weightless on a phone screen, but the systems behind it are anything but. The new race to build larger models and serve more chatbot traffic is turning into a race for substations, transmission lines, backup power, and giant cooling systems. That matters because data centers do not just buy electricity, they can reshape where utilities invest, how fast grids expand, and who gets charged for the upgrade. So the story is not simply that AI uses a lot of power. The story is that the power system was planned years in advance, while AI demand arrived on venture capital time. What is confirmed is that electricity planners in the US and other markets are revising load forecasts upward after years when many expected power demand to grow slowly. Data centers were already a major customer class before generative AI, but the newest AI facilities are denser, more power-hungry, and often need power around the clock. Industry reporting and utility filings now describe projects requesting hundreds of megawatts at a time, which is the scale of a small city or a major industrial plant. That is why this stopped being a niche tech story and became a utility commission story. The pressure is not only about total electricity use. AI clusters can concentrate huge demand in one location, need extremely high reliability, and generate heat that requires more energy to remove. Training runs may be episodic, but inference at scale can become a steady background load if millions of users keep querying models all day. Utilities are then asked to deliver firm power, often before long lead equipment, like transformers or transmission upgrades, is ready. That timing mismatch is where strain begins, not because electrons disappear, but because the local grid was never designed for a sudden step change in demand from one customer. Once utilities start planning new substations, peaker support, grid reinforcements, or transmission expansions, the political question becomes who pays? Data center operators argue they bring jobs, tax base, and long-term demand that can support more generation. Consumer advocates and some regulators worry that if utilities socialize too much of the build-out, households and small businesses may absorb part of the cost through higher rates. That is why the most important number is not only megawatts requested, but how interconnection costs, standby charges, and network upgrades are assigned. In plain terms, the AI boom becomes a billing story when private demand triggers public infrastructure spending. The first stress tends to appear in established data center hubs, where land, fiber, and tax incentives already attracted heavy development. Northern Virginia became the emblem of this, because it is one of the largest data center markets in the world. But the pattern is spreading to Texas, the Midwest, and parts of the Mountain West, where power access looks easier on paper. Even there, developers can run into clogged interconnection queues, local transmission bottlenecks, or water constraints for cooling. That means the headline is not that every home will suddenly lose power because of AI. It is that some regions will face tougher trade-offs first: approve upgrades, delay projects, build new generation, or risk reliability stress during peaks. If the grid case is so difficult, why are utilities and AI companies still accelerating? Because the commercial incentives are enormous. Hyperscalers want capacity before rivals lock it up. Utilities like landing very large long-term customers, and local governments often chase construction jobs and tax revenue. At the same time, companies are trying to soften the backlash by signing renewable power deals, exploring on-site generation, backing new nuclear concepts, and promising more efficient chips and cooling systems. Those moves help at the margin, but they do not erase the core problem that infrastructure takes years, while AI demand can ramp in quarters. If you want to know whether this story could affect your bill, watch local utility filings more than national AI headlines. The useful signals are requests for large load tariffs, rate cases mentioning data centers, transmission upgrade proposals, and public warnings about peak demand or delayed interconnections. Also watch whether utilities say the new customer is paying directly for dedicated infrastructure or whether costs are being rolled into broader system planning. If those filings start appearing in your state, the story has moved from abstract tech hype to something your public utility commission may decide. There are still big unknowns here. Utilities are seeing more large load requests, but announced projects often outrun what is actually energized and running at full utilization. AI hardware may become more efficient, even as usage grows, and some companies may shift workloads to places with looser power constraints. The real test is whether utility filings, interconnection data, and regulator decisions keep confirming that demand is arriving faster than infrastructure. Until then, the strongest version of the story is about rising pressure and uneven local risk. not a universal blackout narrative. The bottom line is straightforward. AI demand is becoming a grid planning issue. The bottleneck is often local delivery, not just total power supply. Who pays for upgrades will shape the public backlash.